Hello students, in this video I would like to discuss infinite series chapter, in which I would like to discuss Cauchy root test. So this is the syllabus of BSc 4th semester mathematics paper 1. Also I shall discuss the examples after seeing that Cauchy root test. First, let us see the Cauchy root test. Statement of this test is that if suppose series an is a series of positive terms such that limit an power 1 by n as n approaches to infinity, which gives L, then the series first one it is convergent if L is less than 1. If L is greater than 1, it is divergent, the series root test. And if L equal to 1, this Cauchy root test fails. So now let us see the proof of this Cauchy root test. Given that nth term of that limit of n term of an power n as n approaches to infinity PL. Now we can give the definition there. Limit of this, given epsilon greater than 0, there exists a positive number m such that this an power 1 by n, this should be lies between L minus epsilon and L plus epsilon for all n is greater than or equal to m. So now let us, we have two cases here. Let me see the first case. When L is less than 1, then we choose epsilon such that L plus epsilon should be is R, that should be less than 1. It means what? L plus epsilon is less than 1 means that is an power 1 by n is less than L plus epsilon, that equal to R. That implies an plus 1, an power 1 by n less than R. That implies if I take a power multiplication by n, so it means it is an, that n gets cancelled, either an should be less than R power n. Since this is, we can treat it as geometric series, since our n is a geometric series with R is less than 1, which is convergent, if R is greater than 1, which is divergent. So now we have here in this case R is less than 1, which is convergent, and when we compare with this Rn with an is less than Rn, then by comparison test this series an is also convergent. And if you take a second case in which let us assume that let L is that an limit an power 1 by n as n approaches to infinity, L is that L is greater than 1. We choose epsilon such that we can take it to left hand side of an power n 1 by n, that is L minus epsilon is R, that is greater than 1, because since L is greater than 1. Then we compare with the n power 1 by n greater than L minus 1, because since it is L is greater than 1 equal to R, that means that implies an power 1 by n that be greater than. When we multiply power of an by n and R power by n, so then it becomes an is greater than R by n, so that anyway it is Rn is geometric series when we have that is n R is greater than 1, this is a divergent. So then, and also we have an power an is greater than r power n. Therefore, by comparison test, this summation in an is also divergent. Now let us see the case 3, when if you take a L is equal to 1, this series test, this Cauchy root test fails. That means what? Consider 1 by n, which is divergent, and means what? If you take an power 1 by n as n approaches to infinity, that is 1 by n power 1 by n, so that's why it is 1. So as n approaches to infinity, that n approaches to infinity, it gives 1. And also we consider that is the this series P series, which is convergent, and we compare with the P is greater than 1, so that's why it is convergent. So then we have again, it is this limit is again 1. So in that case, this Cauchy root test fails. That. So that is why we have when that Cauchy root test only when L is 1. That means what? An power 1 by n as limit approaches to infinity, it is 1. Then only this Cauchy root test fails. Now let us see the examples based on this Cauchy root test. First you take, that is one example, test the convergence of the series n by n plus 1 power n square. When you apply this Cauchy root test, only that is the sum, the series which contains the power something, that then only we can apply this is the n square n cube or n power n, so that in that case only the root is there in that series, then only you can apply, that is the Cauchy root test. So in this case we have that is an is n by n plus 1 power n square, that implies an power 1 by n. So then we have this here an, so that is now you can multiply an power n, so then n gets cancelled each other. Here also you can multiply that multiply with this here, because then only n square becomes n here. So then you can apply the limit as n approaches to infinity, an power 1 by n, it becomes, that is, see that if you take n outside in the denominator and numerator gets cancelled, 1 by 1 plus 1 by n power n. So that is 1 by limit as n approaches to infinity of 1 by 1 plus 1 by n power n. It means it is standard identity, it is E. So that is 1 by 2.71. It means what? It is less than 1. So that by Cauchy root test the series is convergent. So in the second example again we have that is the in the series which contains the power is minus n square, 1 plus 1 by n power minus n square. Here also this root test is applicable for this problem. You take a n here, and then again you can multiply to the numerator power of an by n, so then it becomes 1 n gets cancelled each other, and here also we have that. Then you can have limit of as n approaches to infinity of an power 1 by n, and limit of 1 plus 1 by n power minus n. So then it becomes 1 by e, that is also less than 1. Therefore by Cauchy root test this given series an is also convergent. And in the third example again you have a you test the convergence of the series, in which only the term should be in the expansion form, so that is in the numeric there, but that power is minus 1, minus 2, minus 3, it is decreasing its nature, but thing is that it is a root there. So you take for an as you have in this nature of that series, so that nature of that series nth term n plus 1 power n plus 1 by n plus 1 minus, it is 2 by 1, 3 by 2, 4 by 3, it is n plus 1 by n. So you can take to this power of this an is 1 by n. So ultimately it becomes n should be gets cancel each other. Then you can apply the limit as n approaches to infinity. Again it becomes, that is what here we have 1 plus 1 by n power 1, it is common term. Here it is n and here it is e and it is 1. So when you apply the limit as n approaches to infinity, it is e and 1, that is again 1 by e minus 1, which is less than 1. So therefore by Cauchy root test, the series give an is also convergent. So next, another example, again we have that is summation n minus log n power n, and denominator is also 2 power n power n. So this here also root test can be applicable. And take the nth term of that series and then you apply, that is the taking the power of 1 by n on both sides, then which becomes, that is n here, and then only remains, that is n minus log n by 2n. Then you apply the limit as n approaches to infinity. So then we have, that is n by 2n is 1 by 2, log n by 2n is this here, and 1 by 2, that is power in that here, and again apply as n approaches to infinity. This second term is log 1, this is, so that log 1 is, again it is 0, so that's why it is 1 by 2 only remains, which is again less than 1. Therefore by concluding with the Cauchy root test, the given series is convergent. And the fifth problem, again we have test, that is the convergence of the given series. Only the difference of previous examples and this examples, there is no terms of x in the previous examples, and here is which contains the x here variable. And again you take that nth term of an and take to the numerator power of, that is an is 1 by n, and this in the right hand side it is n should be gets cancel each other, and then apply as n approaches to infinity. So that is n by n plus 1, n should be gets cancel each other, and 1 plus this is 1 by 0, infinity is 0, so that x remains. Therefore by Cauchy root test, the series an is convergent only if x is less than 1, and it is divergent x is greater than 1. So if it fails x equal to 1, so that now we have seen that if x equal to 1, what happens that if x equal to 1, so that nx by nx plus nx by n plus 1 power n, so x is 1, so that is what we have got it finally. This is an identity standard 1 by e, so this is not equal to 0, which is divergent. So in the sixth problem also we have, that is x term here, but only in the first term there is no x term, so that we can see the nature of the series after the first term. That so by after neglecting the first term, we have the nth term of that an is this n plus 1 by n plus 2 power n x power n, so that we can take it to the numerator power of an is 1 by n, and the n should be there, and apply the limit as n approaches to infinity. Finally we have a x there. According to Cauchy root test, the given series convergent only if, that is x is less than 1. If it is x is greater than 1, the given series is divergent. So that now if we take series if take x equal to 1, what happens this nature there. So that is what we are seeing, that limit as an there, so that again e by e square, and again it is 1 by e, which is not equal to 0, so that therefore the given series is divergent. So in the last problem also we have the same term, that only 7th and 8th problem also we have that an is nq by 3 power n, and then again apply the root test, and this given, because when you apply the limit here it gives the finite value and it should be less than 1, which is convergent. Same thing in the last 8th problem also, which contains the x term. This becomes n term of a series is n into x power n, and apply the root test. which gives, that is